Yes. All right. This is the first question for today. The acceleration of an object as a function of time is given by 3t, 3 multiplied by, as you see, the acceleration is not constant, it's a function of time. If the object has a velocity 1 meter per second at time t is equal to 1 second, let's write this. Of course, if the acceleration is a function of time, and obviously the velocity also will be a function of time. So this is velocity, this is acceleration, and position. Uh, what is given in the problem is that the velocity at time t is equal to 1 is given as 1 meter per second. Okay. And the acceleration is given as 3 times t. Okay. I just dropped the units over here. Okay. So I just write this as 3t. And what is the displacement of the object between time t is equal to 2 seconds and time t is equal to 4 seconds? So what is the displacement, delta x, between 4 and 4 and 2? Let's put this subscript. Let's put this subscript 2, 4, which means this difference, right? If the problem is asking about the displacement, that means it is the position difference between 2 points. And what is this difference? X is equal to t is x, the position at x is t is equal to 4 seconds minus the position at t is equal to 2 seconds, right? So this is the question. Okay, what is this? And these are given. So how do you proceed? How do you attack the problem? Uh, First thing is that what we know about displacement uh, or x, we know that dx over dt is nothing but vt, right? This is coming from the definition. And if I multiply both sides by dt and take the integral, of course, you have to put the limits of the integration. This is important. We know that the initial or given velocity value is at time t is equal to t1, right? Sorry, time t is equal to 1 at v is 1 meter per second at time t is equal to t1, right? And let's put these initial values to be like maybe t from since the integration variable is t, from t1 to t2, and since over here the integration variable is going to be dx, and then the variable is going to be x1 to x2. Okay, so if you solve this, on the left hand side you have x2 minus x1. On the right hand side you have to take this integral, and this integral is that we have a function of time. So in order to solve this integral, we have to know what the velocity as a function of time. Okay, so we cannot proceed from here. We have to first know what is this function vt, and how do you find this function. Okay, so wait for this portion of the equality for a while and come over here, that we know also this dv over dt, the time derivative of this velocity function, is nothing but a, the acceleration, and also acceleration is given as a function of time, and this is 3t. So from this, can you find v? Again, the thing you do to find the v, just multiply both sides by dt and take the integral, right? All right. And as you see, the left hand side of this integral is just dv, And the right hand side is 3t dt, and it's very easy to take this integral. Okay, but the thing is, we have to put the limits, and the lower limit is just, let's put v1. The upper limit is v, which is unknown, and the lower limit is, since the velocity is given at time t is equal to 1, okay, so we put 1 over here, t is equal to 1, because at t is equal to 1 second, the velocity is equal to v is equal to v1, which is 1 meter per second. And I will put this over here later. So, and t over here, 3t dt. And it's very easy to take this integral, both sides. The left-hand side is v minus v1. The right-hand side is 3 divided by 2 t squared, but t squared from 1 to t, and 3 divided by 2 t squared minus 1. And what is v1? v1 is the velocity at t is equal to 1 second. All right? Okay. So this is the, we don't know what this is. Okay. This v1 is not equal to this one. Okay. Just this is just an integration constant. All right. And it just says that, sorry. Right. Let's put this, we always, what we do is we take the integrals, okay, from t is equal to 0, and this is v0, and we have to put over here, sorry about this, 0, and this is x0, and we have v0 over here. It's just an integration constant. So, and the next thing is, well, this is v of t. This is nothing but v of t. Why? Because at time t is equal to t, this must be v of that time, the velocity at that time, vt. And what about this v0? To find v0, we have to put this condition, and this is the condition given by the problem. We know that at time t is equal to 1 second, velocity must be 1 meter per second. So when we put at time t is equal to 1 second, this is going to be 1, and this is unknown. We put time t is equal to 1 over here, sorry, 0. And this is 3 divided by 2 t squared, okay? And we put time t is equal to 1. We put time t is equal to 1, this is going to be 3 divided by 2. So from this integration constant v0 is going to be 1 minus 3/2. It's going to be minus 1 over 2. Okay. So what this tell you is that v of t, by using this equation, is equal to 3 divided by 2 t squared plus v0, because v0 can be taken out on the other side, on the right hand side. But we just have found v0 to be minus 1 over 2. So 3/2 t squared minus 1 over 2. Okay. So, and this is the velocity as a function of time. Okay. This is the velocity as a function of time. So just to check that if at time t is equal to 1 second, the velocity is 1 meter per second, you can check this over here. What you do is put t is equal to 1, and this will be 3/2 minus 1/2, and it's going to be 1. So this condition is satisfied, and this is your velocity as a function of time. Once you know this, now you can calculate this integration, right? Okay, so what you do is that just drop this x2 and just drop this t, okay, where at time t is equal to 0, this is the integration constant x0, at time is equal to t, and this is x of t, okay? So over here we have x of t minus this integration constant x0. And the right-hand side, you just put this v of t, which is 3 half t squared minus 1 over 2 dt, okay? So this is the integration that you have to take. And I have to erase this part in order to continue to take this integral. Okay, so x minus x0, and now let's do this integration. What is the integration of t squared? It is t cubed divided by 3, right? 3 divided by 2 multiplied by t cubed divided by 3. And what is the integration of 1 over minus 1 over 2? It is 1 minus 1 over 2t. And this is going to be evaluated from 0 to t. So you get, these are just simplified. T cubed divided by 2 minus t divided by 2, right? And I hope this is clear. Now, what you get is, you get x minus x0 can be put on the right-hand side as plus x0. And this is x of t. The position, we just get the position of this object as a function of time. Well, you might tell me that, well, what is this x0? You don't have any knowledge about x0. Without knowing what x0 is, how can we find this displacement? But in fact, you don't need to know about x0, because all we have to calculate is just the difference between the position at two different times, and you will see that this x0 will cancel out during this operation, okay? So just come over here and just calculate when time t is equal to 0, what is x? Sorry, when time t is equal to 4, what is x? You just put 4 cubed divided by 2. What is 4 cubed? 4 cubed divided by 2 is 2 times 16, which is 32, I think, right? 4 times 4 times 4, and divided by 2, 2 times 4 times 4, 2 times 16, which is 32, minus 4 divided by 2, which is 2, and plus x0. So that means this is 30 plus x0. X at time t is equal to 4 is 30 meters plus x0, whatever the x0 is. And what about x t is equal to 2 seconds? Well, if you put the 2 cube, it is divided by 2, it is 2 square, it is 4. Minus, if you put 2 over here, it is 1, and plus x0. So it is 3 plus x0. So what is this difference then? x4 minus x2 is delta x. 30 plus x0 minus 3 plus x0. And this is going to be 27 meters. Okay. Do you follow the solution, or any questions about the solution?
Hocam,
Yes.
should I speak English or Turkish?
Well, whatever you wish.
Okey'den 3 bölü hani A'da saniye küp cinsinden vermiş ya orada. 3 metre bölü saniye küp.
Aynen.
Saniye küp ama biz sanki A'yı normal metre bölü saniye kareymiş gibi kullandık.
Evet.
Hani onu
Evet. Şimdi yalnız şuna dikkat etmen lazım. Şimdi 3 metre bölü saniye küp çarpı t var burada. T'nin birimi ne? Saniye. Saniye ile 1 bölü saniye küpü çarparsan ne olur? 1 bölü saniye kare. Yani metre bölü saniye kare.
Anladım. Bir
Yani
de özel bir sorum daha olacak.
evet.
Midterm'de integral bilmek zorunda mıyız? Ben unutmuşum hocam integrali de. Eğer bilmemiz gerekiyorsa sınava kadar hemen öğrenmem lazım.
Yani basit integralleri biliyor olduğunuzu varsayıyoruz. Basit integraller dediğim mesela şunu biliyor olman lazım. Herhangi bir polinom veya x to the n diyelim dx. Bunun integrali nedir? Bunu biliyor olman lazım.
X üzeri n artı 1 bölü n artı 1 değil mi?
Aynen. Çünkü bunları biliyorsunuz diye varsayıyoruz. Nereden? Ya high school'dan ya da şeyden. Şu anda aldığınız matematik dersinden.
Tamamdır.
Ya da basit mesela kosinüs x dx'in integralini veya sinüs x dx'in integralini. Bunları biliyorsunuz diye biliyoruz.
Tamamdır. Bu kadarını biliyoruz ama
Bunları
şey
bilseniz
çok...
yeter. Bunun dışında e, kalkıp size kalkülüsteki gibi, matematikteki gibi çok veya üniversite sınavındaki gibi zor integral soruları gelmez. Bunlar gelir en fazla gelse gelse.
Tamamdır hocam. Teşekkür ederim.
Okay. And do you have any questions about the solution of this problem? Anybody else? Okay. So we can just move on with the next question. Let me erase this board. Okay. Oh, next question. Again, it is sent by one of you. A ball is dropped from somewhere above a window that is 2 meters in height. And as it falls, it is visible to a person looking through the window for 2 milliseconds as it passes by the 2 meter height of the window. From what height above the top of the window was the ball dropped? So, if you understand the question, then half of it is done. So let me just put a picture for you to understand or what is asked about the problem. So suppose you have this building, okay, and a ball is dropped from the top of the building, and but somewhere over here you have a window, okay, which has 2 meters in height. Let's call this L, the height of the window. This is what is given in the problem. Above a window that is 2 meters in height. So above a window, well, this is, let's say, the distance h where the ball is dropped from to the top of the window. So this h that we don't know, in fact, the problem is asking this h is the distance from the point that the ball is released to the top of the window, okay? And the problem says that the ball just passes from the cross section or from the projection of the window in 2 milliseconds, right? Because it says that it is visible for only 2 milliseconds. So if you think that this is the portion of the window, the projection, the ball passes in an amount of time which is 2 milliseconds. 2 milliseconds is 2 times 10 to minus 3 seconds. Okay, so this is the picture of the problem. I mean, if you just draw a picture, then half of the solution is done. So the question is, from what height above the top of the window the wall was dropped? So that means what is this h? Okay. So this is the problem. Okay. And how do you solve it? So how do you find this h? Okay. And just with the knowledge of that, if the ball is passes takes this 2 meter distance in 3 milliseconds. Sorry, 2 milliseconds. So what we know about is that if the ball takes this distance of 2 meters with a increasing speed. Well, if you take the coordinate system that y is upward, this velocity is decreasing as it is going down, but the speed is increasing because the magnitude of the velocity. Why we say that velocity is decreasing? Because if the velocity is, let's say, minus 1/1 meter per second over here, and if it is a minus 2 meter per second over here, minus 2 is a lower or smaller number than minus 1. If you think that way, if you think in terms of math, this is it. So we say velocity is decreasing, but velocity is decreasing with this choice of coordinate system, but the speed is increasing because minus 2 corresponds to 2 meter per second, minus 1 corresponds to 1 meter per second, and 2 is larger than 1. Anyway, let's put this aside. If you choose your coordinate system like this is what happens. If you choose the coordinate system like this, uh, and what type of motion that the ball is taking, not only as it passes by the window, but whole of its motion is an accelerated motion, right? And the acceleration is just minus g, which is minus 9.8 meter per second squared. If you take your coordinate system, increasing y is upward. You might have choose your coordinate system as this. If you choose your coordinate system like this, then you must take a to be plus 9.8. But this is my choice, okay? And this is what I do. Okay. But in fact, let me tell you that this choice is, in my opinion, this choice of coordinate system is better because you know the initial point. Okay. So let's choose this. Okay. Let's choose the coordinate system so that y is increasing in the downward direction. In that case, the acceleration is going to be plus. And this is, let's say, the velocity at right over here on the top of the window. Let's call the velocity as v1 and the velocity is v2. So v2 is larger than v1 in that choice. In this case, these are velocities at the top of the window and the velocity at the bottom of the window. Since v2 is going to be algebraically a larger number than v1, because I just chose the increasing direction as downward, v2 is going to be larger than v1. And how these are related to each other? I know that v, in most general cases, v is just v0 plus a times t for an accelerated motion. Okay, so that means v2, okay, is going to be equal to v1 plus g times t. If you want to just relate these velocities, this is it. Well, will this help me? Well, let's think about h also, because the problem is asking about h, not the velocities. So, I mean, uh, why I did this too, why I did this, you just put this aside. This is not my priority. My priority is to express h as a function of time. So what is h? So in most general cases, y is y0 in the vertical motion, v0 y times t, and plus 1/2 gt squared, where since I just chosen the downward increasing direction as the downward direction for y, I have to put the plus in front of g, okay? But initial position of the ball is just 0 because I took my coordinate system so that initial origin is that initial position of the ball. So this is 0. And the ball is released from this, as it says, it is dropped. It means it is dropped, it's just released from rest. This is going to be 0 because v0y is going to be 0. So h is going to be just 1/2 g t squared. Okay. All right. So what is this time t then? If I knew what this time is, right, then I will just calculate h because I know g is 9.8. How can I find this t? Okay, all right. So what do you say? Can I find this uh, time t? Time of flight from the point that the ball is initially dropped to the top of the window, to the place of the top of the window. This is the time. Okay.
I
But
think
yes.
first of all we should find V1.
Okay. So if you find V1 is going to be just expressed by G times this time, right? If you can find what V1 is, then T, time of flight that you should put over here, is going to be just uh, this time, and this time is not the same. Uh, this T prime, sorry, this T, which is appeared on H, this T is going to be just V1 divided by G, right? But how can you find the V1? If you can find V1, then this time you can find and put over here, calculate H. All right. But the thing is, what you know about uh, this part, can you use this part, this information? So the ball takes
Yeah,
2 meters
Mister,
in, yes,
we can find
sorry,
the first of all we have to find V2 right now.
okay,
After that, for example, we will use the down formula like V squared is equals to U squared plus 2GH. So we can find V. If you can V2, we can find V1. So if you, it's enough.
okay. Süleyman says that we can find something in this portion of the motion, okay? And well, the other thing is that there's a relation between V1 and V2, right? And what this relation is, V2 squared is equal to V1 squared, right? And plus 2 times T prime, sorry, 2 times 2 meters L multiplied by G, right? So, and what this gives you? What does this give you? You don't know what V1 is, you don't know what V2 is. Well, you know all this, 2L and G, etc. But the thing is, you know the relation between V1 and V2 from this information. Okay. Okay. How do you proceed?
Hocam ben bir şeyler düşünüyorum ama İngilizcem yetmiyor açıklamaya.
Tamam. Türkçe ama.
Şimdi hocam ben şey düşündüm. Bizim V1 hızımız var. 2 metrelik yolu 0,2 saniyede alabilmek için ne kadar baş hızımız olması lazım? Yani şimdi GT'nin bize katacağı şeyi biliyoruz. Yani hız artışımızı G çarpı T'den bulabiliriz. 2 metre alabilmek için X eşittir V çarpı T'den, yani hız artışımızla yolu bağdaştırabiliriz diye düşündüm.
Okay.
Hani X eşittir V0 artı GT olacağı için GT'yi zaten biliyoruz. X de 2. Oradan ilk hızımızı bulabiliriz diye düşündüm.
Okay, tamam. So what you say is we know this L, okay, right? And L can be expressed as if you take the motion so that This is the initial position. This is the final position. And this is the distance it takes to drop. So to, get this 2 meters. So L can be expressed in terms of V1 and V2, right? That's what you say. Or V1 is going to be initial velocity, right? And let's put V1 and T prime, and plus 1/2 G T prime squared. Mehmet mi konuşmuştu biraz önce?
Yes. Yes.
Okay. So I think what you're talking about this equation.
Yeah, yeah. Exactly what
Okay.
I mean.
So, and just as if we express this distance h as a function of time, but this time and this time are not the same. This time is just the time passes from the drop of the ball from here until here, okay? This is the time. But over here, we can also express, this is another distance, which we know, which is 2 meters. If we express this distance by this equation, because during this motion also the object is doing free fall with the initial velocity of v1. If you think that the motion starts right at this point with an initial velocity v1, this is the expression for L, okay? If it takes t prime time to start from here to here, which is 2 meters, this is the expression for L, okay? Initial velocity multiplied by t prime, which is this time of duration, plus, since we are taking the vertical axis, downward axis as our coordinate system, we have to put plus over here, 1/2 g t prime squared. If you realize, if you accept this, then you are done, because this is 2 meters, this is 2 milliseconds, and this is 9.8, so you can find v1. Is that right? Well, if you express v1 in terms of all these known variables, it is going to be just L minus 1/2 gt t prime squared and divided by t prime. Oops. Are you following this? Are you okay with this? And I will just put, we don't need this. I will just put all the given values in the problem, where L is 2 meters, 1/2, G is 9.8, and T prime squared, T prime is just 2 times 10 to minus 3 squared, and divide this all by
Sir,
2 times 10 to minus 3. Yes.
there's something wrong with time, I think.
With time? Which one?
Yeah, it should be 10 over minus 1. Because it's 200 milliseconds.
Is it? Yes. It is
100
200, it is 200 milliseconds. I beg your pardon. I have to correct this. 200 times 10 to minus 3, which means 0.2 seconds. I beg your pardon. Okay, this is going to be 0.2. And this is going to be 0.2. Okay, so this is V1. And from this, once you calculate what V1 is, you can calculate the time that the ball comes from this point to here by using this equation, okay? Because you know what V1 is, and during this fall, the time required during this fall, or time required to reach this velocity, V1 velocity, is t. So you can find this t since you know what V1 is from this last step, okay, and divide this by G, which is 9.8, you can find T. And once you find this T, you put over here in this equation, you can find H. Okay? Is that okay? Let me express this so that T square is this V1 divided by G, and we know what this V1 is, 2 minus 0.5 G multiplied by 0.2 squared. This is divided by 0.2 multiplied by G. And take the square of this. So this is the expression for H, the answer of the problem. Okay. This is G, 9.8. You put 9.8 over here. This is G, but take the square of this whole thing over here. And this is also G. This is 0.2. Okay. And there is some chat. Okay. All right. Okay. Çocuklar bir mola istiyorum 5 dakika. 5 dakika sonra devam edeceğiz, olur mu? Bir ihtiyaç molası.
Tamamdır hocam.
5 dakika sonra devam ediyoruz.